Okay, in this mini lecture, I'm going to focus primarily on a term that we first got introduced to with the difference of means, and that's the 95% confidence interval. So let me just real quickly remind you, we're working here with two variables, each of which is ratio and scale. Okay? We're working with two variables, each of which is ratio and scale. We first calculated the correlation between these two values and found out that they're strongly positively correlated with one another at about an observed correlation of R equals 0.893. We then went from our test of association, which is the Pearson correlation coefficient, we then went on and we did our first predictive modeling effort in MS-264, where I calculated the simple regression model for these two variables. And let me remind you here on the screen, y equals a plus b times x. That's the basic simple regression model that we work with in MS-264. Now what I'm going to do is I'm going to go to the simple regression output. I'll quickly review our regression model output, and then I'll show how in our regression model B is our point estimate, and we'll look at the upper and lower bounds for our 95% confidence interval. Okay, so you should be familiar with this. We covered this in our previous mini lecture, and from our previous mini lecture, if you will recall, we were able to extract our point estimates for both A and B from this portion, the highlighted portion of our simple regression output. We were able to extract these point estimates to build down here this simple regression model where our prediction for sales is sales is equal to -1 plus 2.046 times the number of sales calls that the salesperson makes. So 2.046 is our point estimate for B. Okay? So our point estimate for B is 2.046. But keep in mind, we're just working with sample data here. We're not working with population data. We're just working with sample data. If we were to draw another sample of salespeople and conduct a Pearson correlation coefficient and conduct a simple regression analysis, our results would hopefully be similar to, but not exactly equal to, what we report here. So what we can do in this simple regression model is we can calculate a 95% confidence interval for B. And remember, B is really, really important, because if B equals 0, in other words, if we fail to reject the null hypothesis, if B equals 0, that means that our independent variable x does not help us predict our dependent variable y. In this instance, we rejected our null hypothesis. We concluded that B does not equal 0 because of the small p-value here. All right? So when we concluded that B does not equal to 0, then we went on, we looked at our regression output right here, and our point estimate for B is 2.046, and that's the value that we use here to build our regression model. So then the question becomes, so if this is our point estimate, what would be the 95% confidence interval? Fortunately, the computer calculates that for us, and it gives us that answer right here. Let me actually make that a little bit bigger just so it's easier to see. And what you see here is that while our point estimate is 2.046, our lower bound is 1.536, and our upper bound is 2.555. Keep in mind that halfway in between 1.536 and 2.555, halfway in between these two values would be our point estimate, 2.046. So the only extension in this mini lecture over the prior one is that, first of all, hopefully I reinforced a few things about the null hypothesis, alternative hypothesis, how to read the p-value and so forth. But the extension in this mini lecture over the previous one is that we go from merely having a point estimate for B, 2.046, to actually having an interval estimate. So we're 95% confident. We're 95% confident that the true responsiveness of our dependent variable sales to our independent variable number of sales calls ranges somewhere between 1.536 and 2.555. Thank you.